So now from a utilities company like RWE, we'll go into our next talk. And I'm really happy that this is, again, a talk of actually two people. So it's my colleague, Jacques, Engländer from Onward. Jacques, please welcome me on stage. You are the lead architect. Yeah? What that means and what you do in your day-to-day job, we'll come to that in a minute.
Thank you.
And yeah, so welcome. And you brought Dominik with you. Hi, Dominik. Nice to see you again. Yeah. So, so Dominik is with Hirschvogel Group. Dominik is the Smart Factory Program Lead. You have lots of experience in that field, Dominik. And well, you teamed up to work on the implementation of the unified namespace, which I think is very interesting. And at the same time, I think it will spark a lot of curiosity and interest, because for me, unified namespace is a great tool, an excellent tool, but I can imagine that not the whole audience has heard about that. So, and how that works and how that might be the missing ingredient to run AI at scale, this is what your talk will be about. So I would say, without further ado, let's get started. I'm really looking forward to your talk, guys.
Okay. Yeah, thanks, Christian. Thanks for inviting us, actually. And again, hi, Dominik. So basically, just a very short introduction why Dominik and I standing here, or at least remotely be here together. Actually, we did a project together based on the unified namespace. I will explain that topic later on to you as well. And actually, I won't talk that much about AI itself. I will more or less focus on the unified namespace as an architectural concept. And later on, Dominik, from his real expertise, he will talk about that topic then, how AI was developed there based on the unified namespace. So again, nice to see you all in this conference. My name is Jacques Engländer. I'm, as Christian said before, senior expert at Onward. We are a consultancy company based here in Aachen. And first of all, we are helping manufacturing companies in their digital transformation. And maybe to give you some kind of idea what we do there specifically, if you imagine you have like the corporate perspective, but also the plant level perspective, our main area and sweet spot is like very in between. So normally when we have those big initiatives and some standards that coming from corporate, we help to bring those standards to the plants. And the other way around, if you have a plant with good employees, with ideas, with specific challenges, we have to bring those ideas and solutions already to the corporate side. So maybe let us start with the presentation. Now it works. Okay, so let me take you back like, let's say somewhat around 20 years ago. Here you see, and I think you all know this man, Mark Zuckerberg from Facebook back then, now it's Meta. And in 2004, this company was launched, and really with the overall goal to connect people, yeah, via social networks at colleges. To this time, this was something really new, right? Also using internet and online tools to do so. Just 8 years later, and you have to imagine that for a company, 8 years, I mean, is a long time, but nevertheless, there was a new mantra internally in Facebook. And this mantra was, data is only valuable if it's connected and if you have knowledge about this data. And there were also previous presentations today where these two terms of data and value came across, and I want to emphasize this later on a bit more. And just this year, Mark Zuckerberg in public said that the main core, the main focus is not any longer to connect and share people in their daily lives, but to really work on this data perspective. And not only when we're looking at Meta, but all the most valuable companies this year, I think it's not a surprise that those companies are really working on and working with data. So for example, NVIDIA, which really was boosted with this AI hype currently. We have Microsoft, Apple, Amazon, Google, and just maybe on part number 7, I think it's Saudi Aramco, so a company working with real goods, physical goods. And all those companies understand that it's not only about connecting data, but generating knowledge. And I think this is also nothing new for you, right? But I want to explain this a bit more in more detail later on. So we see that it's not the problem that we today suffer from too little data, but in my opinion, we suffer from too little structure. And to illustrate this a bit more, I brought you the Goldilocks dilemma or the Goldilocks principle. It's based on a fairy tale from, I think, almost 200 years old, and this explains the following. If we have on the left side something that's too easy, right, or if we suffer from too little data, we make new initiatives, we put more budget on it, we try to elaborate and use more modern technologies, right? And most of the companies know the situation and probably have been in this situation before. But what then happens is they are like landing on the other side of the spectrum, where they suffer from too much data, right? And in that case, often you have some kind of disappointment, also some kind of missing ROI or organizational paralysis. So you don't know what to do anymore, right? And the Goldilocks dilemma says that there is a way in between, like making things just right. And when we're talking about data, oftentimes it's exactly that sweet spot where we understand data, where the data is structured, and furthermore, where the data is governed. And in this case, I think many companies are searching exactly this sweet spot where they have not too less data, but also not too much data to make it pragmatic and at the end of the day to make use of that data and value of that data. And here's a very short statistics. More than half of the data that a company produces is like on the dark side, so it's not seen, it's dark data. 46% of the data in a company is tagged or classified, and this 46% is then further specified or further separated in 1/3 that is actually business critical data, and 2/3 that is in the main cases redundant, obsolete, or trivial data. So you see that the main amount of data is useless at the end of the day. So it's not about collecting data and big data analytics and all that kind of stuff and data lakes just to collect data, but to really make this useful. And as it is, for example, here with artificial intelligence and neural networks, you need to have this one kind of framework that is beneath this, to make this structured and to make this governed, and to, at the end of the day, to speak the same language when we're talking about the data. And the unified namespace now is one approach to do this, one very promising approach to have this kind of governed and structured framework beneath. I'm not saying that the unified namespace is like the only one or the absolute way to go and the holy grail, for example, to solve all your problems. But it's a very promising approach to structure your data in the company. And as you see here, normally you see more or less like two pictures of the unified namespace. The one is on the right-hand side that it looked like the unified namespace is in the middle. And the other one is that you have this hierarchy, which is basically based on the ISA 95 approach. And with the unified namespace, you come up in a situation where you have the digital backbone for smart factories based on this unified namespace. So you have a semantic hierarchy that gives structures to all the data you have in your company, mainly the industry-related data, so based on the shop floor. It simplifies data flows and breaks down silos, but it also is able to share data in real time, right? And to make to be the foundation for several other use cases. And for that, we also call the unified namespace as the single source of truth in motion. And motion means, in that case, in real time. And on the next slide, for all the people in that conference now that already heard about the unified namespace, I just brought a slide on what it is, actually. So it's a single and unified view. It's event-driven in most of the cases. It's hierarchical and also semantic. And basically a digital twin of operations, of course, depending on how many data sources you're connecting. And it's scalable and extensible. So basically the linchpin of all the communication. Where on the other hand, what it's not, and in many cases there are misconceptions about the unified namespace, it's not just a database where all the data gets stored in. it's nothing like a traditional PLC or SCADA system. It's not monolithic, so it's nothing like your ERP system that really runs everything in your company. And one of the most important things, there is no point-to-point integration. So you have a decoupled access of different systems. And this really reduces the complexity for new system integration and also for realizing additional use cases. And you're not limited to a single vendor, which is also quite important when you're thinking of sovereignty. So it's not a rigid integration between systems. And I think Dominik later on will also explain a bit more about this approach looked specifically. And to come to an end here, and also to give Dominik the opportunity to go a step further here, why is the unified namespace now relevant for AI? So first of all, I don't know whether you have heard of the term pilot purgatory, but this is the situation in where you have lots of pilots that at the end of the day are not scaling. And my strong belief is that this is for one big reason due to the missing data infrastructure in your company. And the unified namespace really helps you to start small, to govern right, and to scale fast. Yeah, not only from a technology point of view, but also from an organizational point of view. Furthermore, due to the nature of the semantical hierarchy, it gives you context for AI use cases in manufacturing, which you obviously need. And therefore, I think it's a very good foundation for that. And also, due to the fact that it's normally like really language-like and also human-readable what you're doing there, it's also of a big use for LLM use cases. So it's very close to the human language what we're doing there. And last but not least, it's not only a foundation for AI use cases or digital transformation and Industry 4.0 use cases, but in general for all data-driven use cases you can think about. And Dominik now will explain a bit more about one use case and the approach on how he did this at Hirschvogel.
Okay, let's go. Let's continue with the slides, would be great. Yeah, over there they are. So I will not bother you with our company too much, but I guess you still need to understand the kind of processes that we have. So I have one concrete AI use case that we are building up based on a unified namespace. And it's related in our forging area. So as you see on this slide, we have on the left side the machining area. Here we machine metal and also aluminum parts. And here we have lots of digitization projects already because we are able to follow up individual parts. But in the forging business is really different. So you see it on the right side. It's a dusty environment, and we have much higher lot sizes. And we will jump into this area where we are currently working on one topic that will help us to save costs in the future. Let's go to the next slide. So you see one of our forging presses in this picture, and enlarged, we're having a closer look into this machine. And you can imagine that the forging process looks as the following. So you have this huge machine, and usually you have 5 stages in which the metal parts are being formed step by step into the right form that we need. And at the very end, we're looking at right now, here we see the glowing parts with several hundreds of degrees Celsius coming out of the machine. And here we have the several million euro question whether this is a real good part or a bad one. And this is actually our problem statement because we're not yet able to decide it that quickly when we take it out of the press. And currently we're still doing a 100% final part inspection. This means that every part is inspected by humans, and sometimes it's also an automated process, but the parts are so different that it's not easy to automate it at all. And therefore, we are following one solution approach where we try to predict the quality. So it's a predictive quality AI use case in the end, but as Jacques already pointed out, with this data infrastructure of the UNS, we have the possibility to start small and to get in the complexity later. So what we want to do is to classify those parts that are coming out of the presses and find out whether it's a good part, and in the end, whether the whole forging box that is filled with those parts should be inspected, or whether we can really deliver it to our internal or external partners without testing it and reducing our inspection volume in the end. And currently we're working at the very first stage, but we already started with this new data infrastructure. We're analyzing the kind of machine stops and define some rules for this classification of those boxes in the end. And the next step, and this will follow soon, is we will add the kind of forging tools information that we have. So including some information of how long this tool has been used, how often it has been reused, and all of those parameters coming from the tools, and also from the quality measurement devices that are running in parallel and analyzing those parts. So this will also in a later stage be the part of this classification algorithm. And in the third step, and we're already preparing this, machine data will come in. So those presses, there are really complex systems. There are lots of variables, lots of sensors attached to it. And we are already now starting to analyze what kind of data will be relevant for those AI models that will be trained based on this data. And in order to grow the complexity of this predictive quality model. And in this special case, I can show you some kind of value that we gain from this UNS approach. It helps us really to start small. So we're already now building up this kind of data model that will later on be used, because this predictive quality use case we will do with external partners. And it's a quite handy interface. So in the end, we're talking about publishing this information to some broker device. So usually MQTT is used, and also in our case. And it gives us the possibility to hide the technical complexity of acquiring and publishing this data. Because this data, especially the machine data, is coming from various data sources. So sometimes it's a small sensor delivering data in a really high frequency, and we first need to somehow clean and aggregate the data. In other cases, it's some signal coming from one PLC within the press. Then we have additional PLCs, for example. In some cases, we have databases, for example, for this tool and quality area. And for the machine stops, we're getting this information from our MES system. So it helps us to deal with those different data sources and in the end publish it at one place. And this brings us to the third value proposition. It's a really scalable approach because we can change at any site. So meaning the hardware will look completely different in the case when we roll out this functionality to another press. So we will have other data producers in this case, other sensors, other PLC types delivering different data. And this is possibility to push this information into one common data model. And on the other side, we can run different kind of software based on top of the same semantics. This means, for example, our external partner doing the machine data classification can later then also be exchanged or enhanced by our own models. So it really scales on both sides. So you can use different hardware, and I guess you will always find the case that you have different kinds of data sources and you somehow need to unify it. But also on the other side, you can already start to develop those solutions really early based on this common semantic that you decide early on. So in this case, we're building AI use cases on top of the unified namespace. And it's all about the use cases itself. So the unified namespace is just a piece of infrastructure, but it's really critical to find the right use cases. So this piece of infrastructure makes sense. We can also have a look into other use cases that we are currently implementing. So those are the first two ones marked in blue. Then we have some in preparation phase and some are in the future planning phase. So we are using this unified infrastructure, unified namespace infrastructure for all of our currently running and also future running smart factory solutions. So we are also developing a lot of our automations in-house, and we are changing now to some web user interfaces for steering those machines. And this is the project of the automation web HMI. So also here we are standardizing the kind of information that is published from our automations in order to create some standard web interfaces on top of it, and also expose this information to other use cases. So the status of this automation or of parts of the automation are also relevant for other use cases, such as, for example, this operator control station that we see in this third stage that is currently in preparation. So that's one use case that we have in the machining area. Here we are getting information from our PLCs, so from the control devices of our automations. And we're, for example, extracting the amount of parts that are still available. We are also, based on the current cycle times, calculating how long those parts still will be available. And then we calculate some actionable task list for the operator to keep those automations running. So he needs to bring in some new raw materials. He needs to pick up some finished goods, needs to do some quality checks and so on. And this all lands in this kind of operator control station. And here we, at the beginning, started off without the UNS and found out that it's really good approach to do it in this UNS, because the kind of task that we create there just landed in some kind of web user interface. You see a really small picture in this yellow area here. But soon we found out that this kind of task list is also relevant for the operators and some kind of mobile devices. And currently our platform that we built this solution on, it's just a one-way street, so we can just visualize the data there, but we cannot send some push notifications to our operators with some smart devices. And therefore we are pushing down the whole calculation logic one level deeper into the UNS, and we publish this information in this common data model. And one consumer will be the operator control station, and the next consumer could be, for example, the smart device of the operator, and in a later stage, some automation devices like some automated guided vehicles, whoever takes this kind of job that is being calculated. There is one use case that we are also working on. So currently we're using a rather old MES system that in this current form does not have a web user interface. And therefore we developed our own on top of the APIs that are given by our MES system. And the technology that we used was rather old, and we're currently rebuilding this kind of custom front end for our MES system. And we directly do this on top of a unified namespace data model in order to be flexible for the future. So because we are also re-evaluating the future MES system of choice, and with this kind of unified namespace underneath, we will be able to run different approaches. So we can, for example, let's say the new MES system could publish this information also to this kind of UNS that we come up with, and our operators can, for example, continue to work with their known user interface. But it also works in the other way around. So we can also publish some information between the old MES system and the new MES system based on this common data model. So we see a lot of benefit in the future, and also the possibility to reduce our custom development in the MES space. The last category is the ambition to bring more and more automation into our production facilities. So we have heavily automated machining processes already, but they're usually decoupled. So we have some kind of set of machines, 4 or 5 machines, they're heavily automated, but between those machines, there are still some manual processes. So the material is pushed with some boxes to the next operation that is once again heavily automated. And we have already some use cases on the radar where we will more or less connect those automated operations by some kind of orchestration that is happening on top of the unified namespace. So one concrete example is we're having this automated machining operation, and then we need to bring some inspection parts to the measurement room. And we're currently building up some automations that will pick up those parts at the machining station. We'll bring this with an automated guided vehicle to the measurement room. And then there will be another automated guided vehicle with some cobot arm mounted on top of it, picking up the parts, bringing it onto the measurement machine, and the whole chain backwards. And the whole integration of those individual automation pieces will also happen on this unified namespace, which brings us the possibility to exchange individual parts of those automations. So meaning when we have a new automated guided vehicle supplier, then it will publish the same information and we can seamlessly interact with it. And the same applies for the measurement machines when we integrate new ones. So hopefully there was some interesting insight for you. So you see, for us, it's a real piece of infrastructure, and not only for the AI use cases, but also for automation on the shop floor.
Thank you so much for that interesting talk, Jacques, Dominik. We have room for 1 or 2 questions. So what I understood is it's a super helpful framework tool that helps you to connect data sources. It gives you the flexibility to probably change systems in the future, like that outdated MES that you talked about. I understood it's a good tool to discuss or deploy various use cases. But what I take from this is that there's a lot of stakeholders you need to talk to, and I think you need to spend a lot of caution on when you're designing that topic structure and when you're designing and selecting that UNS platform. So maybe you can shed some light on how you did that together in the program.
Mm-hmm. Dominik, I think it might make sense if you start taking that on.
Sure. Yeah, so somehow you need to manage this piece of infrastructure, and it has lots of components in it. And during the selection, we had a look into getting a solution, all-in-one solution. So we selected a platform that has lots of connections on the shop floor. That's the one piece, but also provides the data harmonization piece in it, and also the kind of publishing piece. So we went for one solution that can do all of it. So we're able to manage the whole stack of the technology, because at each level you can stick to an open source alternative, but we opted for a solution that is easier for us to work with. Okay. That's the selection piece, yeah.
Thanks for shedding light on that. Now, Jacques, how do you build that topic structure?
Mm-hmm. That's a good question. So basically, for all of you that are not that deep and well informed about the unified namespace, so normally you have something that is called topics and events. So an event is basically everything. So for example, machine stopped, right? So this is very specific, and I think everyone can somehow understand this. And the topic now is the whole path in which this event is being published. So for example, machine stopped, if you have just that information, of course, the question is where, which machine, what machine, right? And the topic then gives you the entire path and the entire hierarchy in that case, where this information and where this event is being published. And when we're now talking about designing those topics, I think, and that's I think also the best case and what really worked well with Hirschvogel, is that you have two directions in which you can do this. The one is really top down, which is a bit theoretical, of course. In many cases, it's in alignment with the ISO 95 hierarchy. So you start with the enterprise, then you have a site, an area, and so on and so on. But that's, of course, not like the overall solution for the end of the day and your use cases. And then you have to do something which is more like bottom up, where you have specific use cases, you have specific machines, you have specific lines, etc., etc. And you outline those use cases with different kinds of methods and approaches, whether it's event storming or just user stories, etc. And then you're trying to combine those perspectives. And what you see then is that you have some kind of a very, very good iteration in both of those perspectives, because you see that specific events won't fit in the hierarchy that you initially thought it would be there. And on the other hand, you see that you are missing some kind of hierarchy levels in your top-down approach due to the work you did on use case level. And I think that's really good, sums it up on how to design those. And I'm totally with Dominik here, that you can start quite fast and you can just explore and try out, but you still have the opportunity to fix those things later on. But of course, at some point you need to do it a bit more structured and a bit more set in stone. But at the end of the day, still you can make versions of it, so you can make sure that you will align further and future requirements for that.
All right. Thank you so much.